So just to set the stage, folks, there are a lot of guests. We typically discuss the Kaggle competition that as a group we participate in. Today we have a person from Weights and Biases, Ayush Thakur. He'll be sharing with us some of the tips and tools, usage of weights and biases, and kind of would like to thank him for taking the time to share some ideas of usage of weights and biases with all of us. And with that, take it away, Ayush. It's yours. You can use the screen and share what you'd like to share with the rest.
Yeah, thank you, Srinivas. Sharing the screen real quick. Is my screen visible?
Yes. Only thing, you may want to get your microphone a little bit better. There's echo and there's a little bit of, so maybe get it closer.
Is echo?
Yeah, I think.
Is it better?
Yes.
Yeah. Thanks. Thank you everyone for having me here. I am Ayush Thakur and I work at Weights and Biases as a machine learning engineer. So I'm part of the growth team, and currently I am exploring ways of improving weights and biases for Kagglers. So like I have created a lot of kernels. I'm trying to see what features of weights and biases are really helpful for Kagglers and how it can overall like improve the experience of like training model, like submitting score and seeing like how like the model is doing on the leaderboard and all that stuff. So this presentation will be in 3 or 4 parts. The first part will be me going through my slide deck. It's gonna be, I will try to make it as quick as possible because like slides are good for an overview, but I want to get into like the nitty-gritty of things here. Second part will be me going through some of my kernels that I have prepared, and those kernels will like they are kind of me trying to figure out how Western biases can be useful for Kaggle, and those kernels will, in my like, I believe can give you some opinion or some idea of how you can use Western biases for your own projects and Kaggle competitions in general. I will finally show how you can set up a team account because that was a requested question. And then finally, like I'm up for questions. Also, I want this to be very interactive. So whenever you want to ask anything, please interrupt me in between, and like I will surely answer a question. So having said that, let's continue. So yeah, so like traditionally, like we for software 1.0, we have all these softwares for different like components of software development. We have GitHub for code versioning. We have Jira for uh, collaborating on issues and other stuffs. Like we have this entire stack, but for machine learning, we kind of use hacks. Like we use spreadsheets to log the performance of model or like maintain some text file to see how the whole team is performing. Like the data are like all over the place, the scripts are all over the place. So we or just like Bayes and Biases is just trying to fill this gap with like the stacks of like different products that we have in the pipeline and those that are coming in future. So currently we have 4 products: dashboard, artifacts, sweep, and reports. So dashboard is basically your own repo where you can see all the experiments that you have run. It's really interactive. You can check out, like you can play around with it to get really useful insight. Is where you are tracking everything. Then artifacts is like it's like data set and model version control. So like if you are preparing like from a Kaggle perspective, obviously you will split your raw data, you will create multiple splits like in order to improve the validation. So like data versioning is really important there. And like if you're using different data, you want to also have a place that like remember the relationship between the data and the model. So model versioning is also really important. And we all know that like we go back and like we participate in one multiple competitions at the same time. So having like we will tend to forget which data we train our model on. So like this is really going to be useful. We have suites for hyperparameter optimization. We can optimize like you can do Bayesian search, you can do grid search. Like yes, even random search, but that's not that useful. We all know that. And finally, we have reports. Report is like a text editor where everyone in the team can collaborate, get do editing. Like you can like write your insights, what worked, what didn't work in a form of text. That's really useful. So these are the like tools that we have. It's really framework agnostic. You can use any framework with weights and biases. There's no restriction there, and it's also environment agnostic. So train it wherever you want to. Everything will be same in one dashboard. So real quick, we have Lightning integrations for all the frameworks, like standard frameworks that we use: PyTorch, TensorFlow, Keras, Hugging Face, Fast AI. Uh, it's really easy. You can see like you just have to do like import WANDB, initialize a run by calling wandb.init, and you can just use some integration that we have, say WANDB callback, or you can do your custom loop where you call wandb.log. I will go through them afterward. As I said, it's infrastructure agnostic, so train it on your laptop or on some private cluster, AWS, GCP, Kaggle kernel. Everything will be synced to one dashboard or one project, uh, and that's going to be really useful. So, what all you can track? Literally, you can track everything. You can track loss, accuracy, F1 metrics, uh, like AUC, you name it, and you can track everything, and everything will be at one central place. So you can even compare different experiments. So earlier we used to like have this kind of the logs that we used to get from the framework, and then we used to monitor those things, or we used to like have some sort of spreadsheet or some text file, some doc to maintain all the metrics. But that's prone to human error for sure. So obviously we can use WNB to track the metrics. So this is an example of dashboard. You can have multiple runs and you can compare between different runs. You can use parameter, like there are a wide variety of features even in the dashboard that you can use to extract insights and like train better models using that insight. Side note, you can even use this to visualize the gradients. So I tend to use this uh, to like see if my grade, like if I'm training a model and if there's some issue, I can quickly see that like what's the reason, like vanishing gradient or some explosion in gradient, and that's really useful. Most important thing is you want to see if your GPU is being utilized or not. So yeah, GPU utilization is really handy. And this, like you can, I mean, width and biases captures the GPU metrics on Collab, on Kaggle, on any platform, like any GPU that you have, it will track it. You do not have to do any sort of like installation or any like preparation. It will do it automatically. We also have a feature where you can like capture the code. You can save the training script as an artifact, and like you can compare between different training scripts, and that's really useful because like come if you like want working in a team or you are working solo and you want to revisit a competition like a week after, you want to see which training script trained a certain model, and that can be a starting point. Artifact is really cool because like you can literally track all your data and all your model, and I will show you how I use artifacts uh, like from a Kaggle perspective. Yeah, it enables you to iterate quickly because you have better understanding of what like your current experiment is doing compared to other experiments. So obviously if an experiment is underperforming and you have like in your gut you feel that this experiment is not going to give me a better leaderboard score, you can like close that experiment because obviously you have that insight real time. You can compare different experiments within this parameter importance. So like you can see what hyperparameter is really useful here, what is giving you like the most benefit. You can even see the correlation between different hyperparameters. That's useful. So I talked about dashboard. We also have a table view. Uh, this table view is basically like every row is basically an individual run, and you can see all the metrics at one place. You can sort through metrics. You can like sort in ascending or descending order. You can group metrics. You can even download this table as a CSV file if you want to mail it to someone. Really handy. Like I personally use it uh, by using this tags feature. So that every run that I run, I know that this run corresponds to a training job, this one corresponds to an evaluation job, and that way I can keep my sanity in check. I will show that to you, to all of you real quick. Uh, Hyperparameters optimization, we have this product called Sweep. You can run a lot of experiments using this sweep, and it's really handy with the parameter importance chart, the parallel coordinate chart. You can see what hyperparameters led to what metric that you're trying to maximize or minimize. Really handy. Uh, yeah, again, iterate through the experiments and explore, have team discussions. You can have really good insights from the data that you're logging. It's really easy to set up because like it's just few lines of code. You can set up your hyperparameter optimization. Yeah, and finally, like we have this reports. Like you can see all these reports written by Stacy here. Like it's like there's a team page. You all are running your run and logging in a project. And like if you want to maintain some sort of text around that project, like pick up some insight, share them with your teammates. Reports can be really handy there. Yeah, the dashboards are live. So like if you are training something, you can like in the real time see how like all the metrics. You can even use your mobile phone and check like if even if you're like not at your system, you can track the metrics anywhere. I tend to use it like most of the times personally when my models are training on some GCP server and like yeah, like I'm out doing some grocery. I can see like if my model is training, if there's any crash or something happen. Yeah, collaboration is really easy. Collaborate with n number of individuals on a team, and this is true for academic team. So we also have this corporate team. I mean that's a different thing. That's not of our interest here because we are using Bayesian biases for individual purposes and for academic purposes. And for that, for those two purposes, Bayesian biases is entirely free. You have all the features for free. We also have this uh, platform called Fully Connected. It's like a place where like machine learning engineers and authors and like individuals who are working at OpenAI or are part of some really good research organization write blog posts. You can like start your own discussion to like if you want to ask something. We have a ton of blog posts here and they are really handy. I mean, if you want to learn some new technique, it can be a good place to start if you find a blog post. And you can even write your own blog post and submit it here. Yeah. Finally, I will just go through all these slides real quick. These are basically the companies that use Bayesian biases. So like, outside the scope of Kaggle, there are a lot of companies that use Bayesian biases. For example, Latin Space, OpenAI, Wadwani for agriculture, John Deere, Lambda Labs. I mean, so why use Bayesian biases? Like if you are training a model, it helps you train reproducible models because you can see your configurations, you can have all the metrics at one place, so you can like the chances to reproduce your model is high. Uh, You can do all sort of really cool visualization, the metric visualization. We have custom charts wherein you can create your own custom charts and like use that to visualize really good, like say for example, activation maps or heat maps, confusion matrices. Those are really interesting stuff, and it's really easy to integrate. Trust me, like if you have your training script, like your own entire pipeline, it will just take few lines of code to integrate weights and biases. It's really easy to use, and I will highly recommend you to give it a shot at least. Yeah, I mean these are some of the like quick links. I will share this slide deck in the in the community so that you all can check out the docs or like all the collab notebooks that are linked in this notebook like to try out. And if you want to reach out, you can either use my Twitter handle or you can mail me at ist@wnb.com, or you can simply DM me on the TWIML community. I'm active over Slack as well. Thank you for the time for this slide deck, and I will quickly move to the demo that I have. Any question here, real quick?
No, seems to be none.
Okay, cool. Yeah, maybe I thought that am I even audible? So I was like a bit worried. Yeah. Anyway, so I wrote this kernel. Let me share the link in the chat real quick. I will share all the links in the Slack as well. Uh, yeah, did all of you get the link that I shared? Uh, yeah, no, it didn't go to everyone. Yeah. So I wrote this kernel just to walk through the steps that are required to implement weights and biases for your training pipeline. I will just really quickly show you what are the steps that are required. So, I mean, yeah, I mean, you can ignore all this stuff. These are just to like talk about, yeah, all the cool features that we have. You can even check out this short video on weights and biases. It will give you a really overview, a good overview of this product. Yeah, so the first thing is to install Vixen biases. It's pip installable. Just do this. You have Vixen biases in whatever system you want to have it, local system, some GCP server, instance, or AWS or Kaggle kernel, wherever. With Kaggle, Vixen biases is like pre-installed, so you do not have to install it. But like I tend to use upgrade so that I have the latest version of Vixen biases because like every week there's a new version that's rolling out, and like like it's good to have the latest version uh, for your pipeline. Next up, you have to import weights and biases, and you have logging. That's easy. Call import vandb and call vandb.logging. So, like if on a platform like Kaggle or Collab, you will have to call vandb.log in every time you start the kernel. But for your local system or for some system where it's not like on demand stuff, you just have to call vandb.login once and you are set. Uh, yeah, I mean, I a quick like context of this kernel. So this kernel is for plant pathology 2021 competition, wherein there are some images of the leaves. Those leaves are from, I guess, apple tree, and the task is to classify or predict the disease of that leaf and predict if that leaf is healthy or not. So I'm training a simple multi-label classifier here. Uh, okay, Yuri, you asked a question. I think running it on Collab and then submitting to Kaggle is better use case for a lot of Kaggle competition. Um, See, it's up to you. You run it on Collab, you run it on your local machine, you run it on Kaggle itself. It's up to you. Uh, I find like all way comfortable. So if you want, you can run it on Collab and upload that as a Kaggle kernel afterwards. Up to you. I mean, I will not recommend of that. I will not say that this is a best practice or that is a best practice.
Yeah, like I could
Coming
even run
back
it.
to the,
Sorry,
yeah,
quick question. Yeah, just a quick follow. So I can even just run it on my local, like I have a local machine with 2 GPUs.
uh,
So I could just even do all of this there, right? Like on my local machine, and it's just everything is just logged to my weights and biases account, right?
yeah, you can use your local system as well. Everything will
Okay.
be logged to your project, and you can use the same project and log from, like, if you want to use Kaggle kernel, like
Uh-huh.
say for example, you want to create another model at the same time, and you're using, say for example, Kaggle kernel, you can log up to the same project at the same time. No
Oh,
worries.
nice. Okay. Okay, thanks.
Uh, yeah.
Hi,
Coming back to the
Ayush.
kernel, yeah, yeah,
Sorry, can you hear me?
yeah, I can hear you.
Thank you. Just a quick question about the login. So
Uh,
by the time I hit the login, do I have to input my credential in the interactive session? Because my concern is that can I run this in a Kaggle kernel in a background mode? Like,
yeah, good question. Yeah, so you can use Kaggle secrets, like, yeah, you can use Kaggle secrets, and you can like attach your authorization key there as secret, and you can use this code snippet and even use it.
okay. Cool.
And like,
Yeah.
yeah, when you call vandb.log, and if you want to find your authorization key, it's like just go to vandb.ai/authorize, and this is going to be your authorization key. Cool?
Okay. Cool. That's very helpful. Thank you.
Yeah. Uh, yeah. So next up, yeah. So like I install Basin Basis, I did import and I logged in. Next up is, since I'm training a classifier, there must be some config like number of labels, the size of the image, all the stuff. If you're using Basin Basis, you can log in your configs, and I would highly recommend that you use a dict. Like even if you're like if you are using say some YML file or some JSON file, even you can log that on like as config. But if you are like doing something like this, so I would like, because I have seen Kaggle use class config and then have like all the like variables written like that. I will recommend you to use dict. This is the basic input pipeline for this classifier. I'm using TensorFlow, so tf.data is being used. Visualizing a batch of data. I'm using an efficient V0 to train here. I built my model now to train with weights and biases. Uh, Four important key building blocks. vandb.init. These are the key APIs that you must be familiar with. Uh, vandb.init, vandb.config, vandb.log, and if you want, optionally, you can even use vandb.log artifact to log your train model as artifact. So here I'm initializing the model, compiling the model, and then I need to call vandb.init to start a new run. So this, so very important arguments here. So you can name your project here. So plan pathology. So everything is going to uh, my profile under the project plan pathology. Uh, uh, yeah, everything is going here. Close this real quick. So all these runs are here, and you can visualize everything interactively. You can visualize the metrics. Uh, yeah. So another important thing is config. So I am passing in the dictionary as config. Uh, Group and job type is really interesting. So you can group is basically like, imagine this as a top level experiment. So here I have named group as ResNet. So I'm training. So all the ResNet models that I'm going to train is going to get under the ResNet group. And job type is basically, what is this run for? Are you training a model, or are you evaluating a model, or what are you doing? So you can specify a job type. This is going to be really handy, because then you can arrange all the runs using the group and job type feature. So for example, if I want to group all my runs according to job type. So you can see I have, like, there are multiple job types like upload data set, data split, model, train. I have trained like 11 models. Evaluate, I have evaluated 3 times. So this is really handy. This is going to be really useful. And when you group, you can obviously all the runs will be grouped together. Uh, yeah. The next thing is group by job type. So if I also group by job, group by group. Okay, let me close this real quick. Yeah. So yeah, the first group was efficient net, another group was RESTnet, and then I'm also sharing some modular artifacts. So this is another group. So let me run it through the efficient net. So there are multiple models. So yeah, obviously you can see groups. And here you can see in this AUC chart, group RESTnet and group efficientnet. So you can compare different groups. So you can use group and job type, like however you want to use it, whatever you feel is going to give you really good insight. Next up, onedb.config is again, like if you want to use it to update the config. So like here I'm updating the config, like since this is a baseline model and this is a Kaggle competition and a new auto competition. So just some handy feature here. Let me really show you the group here. Yeah, let me group by job type as well. So this is an individual run or an experiment that happened. So all the configs are here: architecture, batch size, epoch, image height, 224. So you have that information on what configurations you are training your model. This is really help. This will save you a lot of time. It will save you from rerunning the same experiment or the same configuration again because maybe you just forgot about it or like you lost the model. So I'm training a model here. Since I'm using Keras, I can use a Keras integration that we have with recent biases. It's just a callback, OneDB callback, and it will take all the metrics, all the system metric and log on the dashboard. So like in your Keras TensorFlow pipeline, instrumenting recent biases is as easy as importing, logging, like initializing, and then finally training with OneDB callback. That's it. You have your weights and biases dashboard with the project, with the run. So suppose you will want to ask a question like if you have, for example, a custom loop. So we have this OneDB.log feature. So I will show this next. OneDB.log is the lowest level API. So even OneDB callback that I showed is using OneDB.log under the hood. So OneDB.log, using OneDB.log, you can log in literally almost everything. So you can log float values, you can log integers, you can log images, audio, uh, segmentation mask, bounding box. So if you check out this documentation of for logging, you can see you can log arrays, you can log segmentation mask, you can log bounding box masks, sorry, bounding box. You can log audio, you can log video, text, even molecules, and even HTML. You can log all these histograms, uh, custom charts like bar graph, histogram, PR, ROC, confusion matrix. Like there's a lot of things that you can do using OneDB.log only. Here I'm using OneDB.log to only log the AUC metric, the validation AUC, and the validation F1 score that I receive after calling OneDB.evaluate. Yeah, and then obviously you have train your model. You want to save the model. You can save your model, and then you can save that. You can save this model locally, and you can even upload the saved model as an artifact. I will show you two quick artifact dashboard, which will give you even better insight as to how powerful artifact can be. Yeah, so you can use this kernel as a baseline thing or like as a OneDB 101, just to pick on features. And feel free to ask me anything in the group, or you can DM me wherever you want to. Another cool feature is that you can, like, all the configs that we are logging, everything that we are logging, you can do, like, you can filter and group. So in this dashboard that I was showing, yeah, you can even filter, like, say, if I want to have all the runs or all the experiments that crashed, I can do that. I can add some other filter, like, say, I want to check for epochs that are, say, 10, and then it will only show the runs with epoch 10. So you can use this filtering feature as well. This was basically instrumenting weights and biases, like a 101 stuff. Uh, yeah, moving forward, there is this competition called Human Protein Atlas Single Cell Classification, and in this kind, I just want to quickly show the uh, ability to log segmentation mask. So in this competition, when I started out, I really wanted to understand how the data looks, and like what does, like, they have provided a tool to do this self segmentation, the competition host. So I wanted to see how this tool is working and how accurate the tool is. So I use Bayesian biases segmentation mask, like logging capability to log all the segmentation masks, and this is the result here. So say I log the cell along with the segmentation mask. So this will be visualized as like this overlay. And I can literally go here and select the class that I don't want to say visualize. Say I can turn off some of the segmentation marks that I don't want to see. This can be really useful. You can see that the segment, like from this, I quickly got the insight that the segmentation tool that they have provided is really useful, and it's like really working accurately on the training data at least. Uh, okay, so Mehmet asked me how I can save the validity token. So if you are using secrets, like maybe I can answer this at the end of the presentation.
Yeah, that's
Show
fine.
it very quickly.
Yeah, that's fine. And the segmentations, that's really cool. Like, how much? So can you just? Sorry, I missed the code to create this overlays.
Okay. Yeah, let me show you here real quick. For creating the overlays, the code is not gonna be very lengthy. It's simple.
Oh,
So we
nice.
have this db.image thing. So here it's kind of a dictionary. The mask keyword, like in logging mask is a dictionary. So if you don't do this and you just call like do this image can be the path to that image or a numpy array, or yeah. So that will simply log the image. Like yeah, this is just an image, right? And the mask is basically an overlay. So you can provide the
Mhm.
overlay as a dictionary, wherein this is like predictions and then ground truth and the simply mask data. This is just an array of mask. I can share this link in the like in the Slack, and you can check out how I did this. And it's really good. It's very easy. It's not that troublesome. And I also have a simple report that I wrote for segmentation logging, and I can even share that with you. It will be
Thank
easy
you.
to understand. Yeah, going ahead. So in this competition, the first thing that I did was to understand the data, and I used the segmentation feature to see the cells. So since it's a classification, so obviously the first idea that came to my head, like, it came to like everyone's head in that, like every participant in that competition, is to basically segment, uh, create some sort of single cell uh, image data set. So like basically use the segmentation mask, get a single cell, and then train on those single cell. We had like image, the labels for image. Yeah, the labels that were provided were like image centric. The entire image was that label, but individual cells might not associate to that label. So I mean that's a part of the competition. So let's ignore it for now. But yeah, the next idea was to, after understanding the data, the next thing, obvious thing, was to create a data set with single cells. So I wrote this discussion post about that. I finally completed a single level cell level data set, and it's just the data set with single cells in it. And it was like it took me really like 2 or 3 weeks to do this, and there was a lot of images that I mean, and images were from different sources as well, because they have provided this competition data, and there was this publicly available data, and they have provided this like really good kernel to download the data. So I use artifacts to create this data set. And when I will explore this, so this is an artifact dashboard. So you can see that there's some raw data, there's some split, some stratified split, and then single label. So like since it was a like every image had multiple labels. So first I saw that like how many images just have one label associated to it, and like most of the images just had one label. So I created a single label a data set. I made a split of that. I trained on multiple splits, and then I thought that I really need to create cell level data set. Yeah, so yeah, let me explore this real quick. Yeah, so this is a bird eye view of what I did to create uh, the single level data set. Yeah, this is the data set, I believe. Yeah, I will just quickly walk you through what I did here. Um, yeah, so this here is the raw data set, right? And I created some splits here, splits. I trained some models, so I know that. So like I'm revisiting this dashboard, say after 3 months, but I can totally see what I did. Uh, yeah, I mean, I also created this single label data set, and using this single label data set, I created multiple space. These are basically different folds of the same data set, and then try to train some model. But yeah, I was creating a single label, single cell data set. So I use this competition data. I also use the publicly available data set, created this really nice CSV file here for the publicly available data set. And I, like, since it took a
quick
lot.
question.
Yeah.
Quick question. So throughout this dataset process, you just initialize some code for the artifacts, and after that, as you create the splits and so on, weights and biases automatically tracks it, or do you need to do something in weights and biases for each of the splits and various things that are forking off here?
Yeah, great question. So, yeah, like this is kind of a bird eye view, but yeah, like for every single step. So, like every circle is an artifact. It's like either a data or a model, and every square is basically a run or a job that I did. So, like for every artifact to be logged, I need to initialize based on message again, log that CSV file or raw images as artifact. So like to answer your question, I have to do this every single time. It's not like I uploaded the raw data set once and I can use this UI to like create space and all that stuff. Did I answer your question?
Could you repeat what you just said? So you said that you, yeah, just go ahead and repeat what you said. I missed.
Yeah. So I'm saying that like every circle here is basically either a data or a model. But in order to log that file or that model as artifact, I have to like use the same code snippet basically, but I have to use it every time I am logging something as artifact. Uh, if you
Right,
want, I
but
can
once
show
you have said, yeah, could you show the relevant part where you've done the setup? So I guess my question is, once you set it up to log, let's say, your data splits, do you need to do it or do it something with respect to weights and biases every time, or will the setup automatically know once you've set it up that, hey, I need to record this split as part of artifacts?
No, you have to do it yourself every time. Recent biases will not be able to track because like this data set creation or model training can be scattered across different machines. So Western biases will not have like that insight that you are using different machines that it can like make this graph on its own. So you have to manually log every time that you do it.
I have a follow-up question on that. So I know I need to associate a model or data set to a artifact. So essentially what you mean, artifact is a node in the graph, right? How could I assign the edge between data set and model, like what you show in the graph?
Yeah, great question. Show it real quick. Yeah. Uh, yeah. Just to answer the previous question, so like uh, here in this kernel, I am creating a single level split. So yeah, let me walk you through real quick here. Uh, yeah, I guess this is it. So this train.csv file is the raw data. Uh, I am logging this raw train.csv file as an artifact. So I have to use this code snippet. I initialize a vandb run. I call vandb.artifact and raw. So raw here is basically this. So if I go here file, this is train.csv that I logged here. This is a data set. So this is a type data set. And then I added like call add file, and then I can like provide the path to that file, and then log artifact. So I am like uploading the whole file as an artifact, and then I can end the run. So the end result is this file here. And in the graph view, if I check, so this is where the raw data set resides. So this is the first thing that I did. Then I created this random train and validation split. So I just called train sklearn train test split. I have the train split and the val split, and then I am logging the train split.csv and val split.csv artifact. So I have to redo it again. And to answer the next question, how to like create these edges. So once I log this raw data set, if I go here in the API, I have this run.use artifact. So when I do run.use artifact, and you can see the same path here, I circle HPA raw v0, and then so here I have the splits. I am again initializing a vandb run. Since I am going to use my raw data set here, so I'm using that raw data set, which is basically me associating this new artifact to a previous artifact. And then I am like again calling it vandb.artifact and giving it a new name, split. And split here is this. So let me go to the graph view real quick. So from raw data set here, yeah, let me zoom it a bit more. From raw data set here, I went to split, and then I have logged the train split and val split. And if I check the files, I will have train split and val split. And this way, by using use, you can create this association between different artifacts. Did it answer your question?
Yeah. I think setting the prefix is a way to do that. And another thing is, I just learned that you can upload the data set or model to an artifact. Is there any space limit?
Yeah, so for a free account that you will create, you will get 100 GB upfront that you can use. You can you can use 100 GBs of storage for free. You can even like ask for more data storage, but maybe that's billable. I don't know at this point of time. I can answer that later on. But yeah, you will get 100 GB, and you can even go back if you don't require some model. If you want to delete that model, you can selectively delete that model. You have that ability. So let me show that real quick if you want. So there's this vandb.settings page. When you will create your account, you will have this settings page as well. So this is your storage plan. So I have 100 GB of data. I have used 36 GB. And you can click on this client storage, and you can basically see all the artifacts that you've stored. So this bird clef is taking 7.9 GB. If I go to bird clef, and then artifact, and I can go there and maybe select the files and delete it. Did that answer the question?
I see. Thanks. I think 100 gigabytes is more than enough. It's pretty big.
Yeah, that's
Thank
true.
you.
That's true. Yeah, I'm not exhausted even 50 GB still yet because I tend to keep my storage like clean. Uh, yeah, so I was going through this graph view. So yeah, I mean, you got the overall picture that you can use artifacts to like do this whole stuff here. And like what I really want to highlight is that since I use public data set and I had to download like for every label one at a time. So I downloaded the images for actin filament, for negative class, for aggression, for nuclear membrane. And then I have to do some steps and processes just to get this label cell level data set. I mean, yeah, it took me some time. So like either like if I was not using Artifact, I would have used maybe some notebook or some spreadsheet or something like that to use it. And there was scope of human error. At least I kept my sanity. And that's the point that I want you to take home from this quick demo here. Uh, and this is another artifact that I want to show because here I have saved a lot of model. Okay. Yeah, so like again, some files, some raw data, some splits here, like stratified splits, some random splits, train some models. And like here, even I have maintained that, say, I started with V0 for efficient and V0. And in the overview, I wrote some note that it gave me a LB score of 0.809. The single best for efficient and V0 gave me 71.3. I then trained efficient and V4 with 512 cross 512 image resolution. Earlier I was using 224 to 24. It gave me a 74, so a huge jump. So yeah, I mean, everything is in one place. I can revisit it. I can take better informed decision based on the data that I have. Yeah, any more questions so far? Or also, like how much time do I have, or I have already crossed that?
No, don't worry about that. Keep going. A lot of benefit by you taking the time, and so take the full 2 hours if it's needed. As long as people are interested, it's something very useful. So keep going. Don't rush. Take your time, and we'll use the remaining time if there is any.
Yeah, I mean, I really want to like talk about VanDB tables. It's kind of it's a new feature. Like it's been a few months that it was there, but still in better version. And at the end of this, by the end of this month, most probably we will have a full-blown release of this feature. But I really want to give it a sneak peek because trust me, I used this recently and I felt that I had superpower. And not saying that because I work for Weights and Biases, but I actually felt that. So what is VanDB table? VanDB table is basically, so far I showed that I was saving the dataset file or the CSV file as artifact, and I was also saving models. So like if I'm using Keras, then .h5 files. That's great. So far, so good. But I also want to visualize individual images. So what I used to do earlier, I used to like have my data loader, and I used to be like run the like iterate over a single batch. I used to plot it, and then I used to see, okay, yeah, this is the image, this is the image. Cool. But I want to visualize the entire image at once, and I want to have some extra features as well without writing any extra line of code. I don't want to spend time writing code for doing some exploratory data analysis. I don't like exploratory data analysis that much, but yeah, it's important. But again, talking about tables, this is, yeah, let me open a link real quick. In this kernel, yeah, this kernel is for plant pathology as well. So again, all the images will be leaves. So step one, and like whatever I'm going to say now is going to be very useful from a Kaggle perspective because we start with raw data set. We can upload the raw data set, like we can upload the CSV file, train.csv file. I don't find it really useful to upload the raw images as artifact because, again, from Kaggle perspective, the data set is going to be constant, more or less, and you're gonna just create splits using the CSV file. So, like, if you have the CSV files in order, and you know what model use what CSV file, and I mean, you can use the path to the image and all that stuff. So, I usually use CSV files as artifact, but with tables, I can even log an entire, like all the images. Uh, Here, let me click on this and show you the interactive dashboard. So here in this code snippet, it's really easy. Vandivi.init, which will initialize the run. Then here I am uploading the train.csv file as artifact. I'm iterating through each image. And then, yeah, and here I created a table, vandivi.table. So vandivi.artifact will create an artifact. Vandivi.table will create a table with some columns like ID, image, label. So something like pandas data frame, but here the panda, like consider this as a panda data frame, but with rich media and a lot more feature like in a centralized dashboard. So I'm iterating over each row of the data frame, and then I'm adding uh, the image name, the image itself, and the label like to the rows of this table that I have created, and then finally log this table as yeah. I just log this table, and then at the end I log this as an artifact. So the entire thing is being logged as artifact. So now if I go here, let me quickly show this. So what files do I have? I have train.csv file because I logged the train.csv file artifact. I have this data table.json file because like once I create this table, like it's like a JSON file which renders a really nice table on this dashboard, and the media is basically all the images that we uploaded. Yeah, let me quickly go through the table here. Yeah, so this is the table. ID is basically the name of the image. All the images you have at one place. You can uh, like click on the image. You can see the bigger picture of the image. I have only uploaded image for resolution to 56 or 256. So if you want to upload a 512 image, feel free to do that. You will have better resolution here. Cool things that you can do. I have also uploaded labels. So first and foremost, I can group by the labels. So I know that for healthy label, I have 4,624 images. For this label, I have 200 images, and I can literally visualize all the images that belong to the label healthy. Fun fact, you can even see that this image, for example, here, like since I have gone through the images multiple times, I know this do not belongs to a healthy image. It belongs to a label called Audrey something. Yeah, Audrey mildew. So yeah, it's like there's this white kind of Audrey stuff on the images, and it looks like this here as well. So I know that there are some mislabels as well. Can I then find which image is this? Yeah, I can do that. If I click on ID, do this column setting. This panel was showing me ID count, but I can also see the name of the images as well. Uh, yeah, so this image is basically this image. I can note it down and I can remove it, or I can label it correctly afterwards. So yeah, so moving from model-centric development, I moved to data-centric development because I had this informed uh, like insight by logging my data set as table. So I am grouping everything as label. This is cool. This is really interesting. I can even filter it out. So like, say example, I just want to look at complex label. Like, yeah, I applied it. Like, let me ungroup it real quick. So all the images here belongs to the complex class. I can see and have like this, like I can train my own brain to understand what complex label is. I can find out if there is any label which is misclassified, etc. That's the first part, upload raw data set. The second obvious part is to create split, right? So I'm creating this raw split here. I have created some stratified split. Uh, Again, I can then again create a new run. Since I'm using the raw split, then one call use artifact, and you can see raw data here, so that I can associate my splits to the raw data. Then uh, created this artifact, so split data, like this is the name of the artifact. Added the files, train, valid, created the table, again ID, image label, and then here I added this new column called split, again iterating through each file and adding rows to the table and uploading that as a table. Let me visualize this real quick. And this is going to be really useful because earlier you just grouped by uh, the truth or the raw value. Now, if I click on this, I can even group by split, and I know that there are 14,000 images in my train split and 3,000 in my validation split, and I can literally see the distribution of labels in like individual splits. So I can see that scab is like got a lot of images, healthy got a lot of images, throwby complex got only 132 images. So like there's huge class imbalance here. So we have to figure out how to mitigate this class imbalance. You can totally do your uh, like pandas dot plot bar stuff and see the distribution. But again, I mean, this is basically integrating Western biases in your own entire pipeline. Like you might think that yeah, I can do this locally as well. Why to do this whole jargon just to find the distribution? I take that question, I understand that question, but the next thing that I'm going to show is something that's really hard to do it by coding it out. Yeah, so I group by states. I can see the distribution. So the next step is to train the model. Here I'm not training the model, but I just created a Kaggle data set just to show how you can upload the data, the model as artifact. So I have just logged the model as artifact. If I go here, there are two models that I have logged, efficient at B4 and efficient at B0. Uh, so I have trained the model. Now, I want to visualize, like I want to see how my model are performing on the validation data set. So like on example basis. So here I am, again, initializing the run, using the split, using the model, like using the split that I trained my model on, using the model that I am going to use for the prediction. Then here, iterating through each file. Okay, let me see here. Yeah. Uh, yeah, I am creating the predictions here, doing the prediction here. Once the prediction is done, I am appending that as a column here, validation with the key guess, and iterating through the validation like DS, and then logging the image name, the path to that image, the label, and the prediction that I have as row. Yeah, as row to the table that I have created here. And let's go to that data, that table, and let me just show you what cool things you can do with this table. First and foremost, this is the table view. You can totally see that I have also logged the logics here, uh, along with the true label and the guess. So yeah, I mean, it feels as if it's doing okay, but here there's a like this is healthy, but it's predicting it as cap. Maybe because there's this like patch here, maybe because of some lighting condition, and because of that, it's maybe misclassifying it as cap. If you go through the cap images, you will find such patches. Yeah, you can see here, this is scab and there are some patches here. So obviously it's classifying as scab. So first and foremost, if I group it by the true label, so this is healthy. I can see like how my model guess is distributed across different labels. So I can totally see that my model is predicting most of the healthy images, there are 925 images that corresponds to healthy in my validation set. And out of 925, 872 images were classified healthy, and 32 were classified scab. This might be because of all these lightning conditions. So I might want to use some like color-based augmentation technique to like reduce this, like reduce the effect of the lightning constraints here, right? Uh, this is me, yeah. Let's go through this label, the complex label. You can see the model is doing really bad for this complex label. It's just predicted 60 out of 321 images that belongs to complex. It's only predicting 64 as complex. It's predicting most of them as scab, frog eye, leaf spot, and complex. I mean, they have like weird uh, labels here, but yeah, I can see that complex has been hurt here real bad. Powdery mildews doing good. So I can just go through every distribution here. I can see which label has been confused the most, and I can then maybe filter by that label. So like if say for example truth here is complex, and uh, where's my guess? Yeah, guess is also complex. So I can know that, and let's ungroup it. So I have all the 64 images that were classified correctly, and I know that. But more useful is that which are not complex. So I can just go through all the images that belong to the complex label, but they were like guessed wrong. And I can look at the images. I can get some sort of insight as to why that is happening. So really interesting, really cool here. Let me remove all these filters. Yeah, cool. Next up, I did it for one model, but I want to compare different across models as well. So what I can do is, uh, yeah, I can compare across multiple models. So here, I have efficient at B0, which gave me a LB score of 71.3 and CV of 79, and efficient at B4, which gave me a CV of 32 and 73 LB. And let me go to this graph real quick. I have not provided the link here, no problem. Yeah. So this file prediction belongs to efficient at B0, and this belongs to efficient at B4. So see if I'm here, and I have opened my table view, I can click on this. Like you can see here, a tool compare icon. I clicked on it, and I can literally compare between, like see the prediction of two different models. Let me quickly do few modifications here. Yeah, this is a table, like better view of this whole thing. So see if I group by truth here, uh, yeah, this first view belongs to efficient at B0, and this belongs to efficient at B4. And let me quickly look at the guess. So for complex here, we know that efficient at B0 was like, yeah, so this belongs to efficient at B4 and this belongs to efficient at B0. Sorry about that. So we note that from efficient at B0 that complex was really doing bad because most of them were misclassified. But when I train a bigger model, I can see that out of 321 images, my model predicted 134 as correct class. So obviously increasing the model capacity helped me like improve the guess here. So I am comparing between two models here. This is really useful. What else can I do? Yeah, I did this. I can also see the distribution. Let me go back, table file. And if I group it by ID, I guess, no, not by ID. Let me do it by truth. Yeah. So here, if I look at the guess, so this blue belongs to EfficientNet B4, and this, I'm colorblind, sorry. So whatever color this is, belongs to EfficientNet B0. And you can totally see that increasing the model capacity helped with better predictions. I can totally see the overlap. I can even see the logics here. So if you see the complex class here, and if you see the score for the complex class, where's the score? Yeah, complex class. You can see that for efficient at B0, most of the probabilities like logics were like 0.20, 0.40. But with a bigger model, like this moved toward this side. Since I was training with uh, cross entropy, I want my logics to be above 0.5. Since like even though this was multi-level classification, but I converted that to a multi-class training thing. So I should have like single like ID which associates to that multiple label, but whatever. You can see that training a bigger model pushed the distribution of the logits towards 0. Like, yeah, like towards 1. So I can see that this is totally improving the model. So cutting like summary with table, I can look at like images and like example level. I can see how my model is performing on individual images, and I can really draw insights and help improve, like help train like from these insights I can train better models, and that's really useful. I mean that's table for you guys. Yeah. Any questions so far? I mean, this is kind of the end of the thing.
Yeah, I have a question, please. This is really cool. In that dashboard that you have, can you get like the ID of the image that you click on? Let's say for something now that has a false, something that was incorrectly classified as cab. Let's say you notice it in the dashboard. Can you get the ID so that you can remove it from the data sets and then train the model?
Yeah. Let me show that real quick. Let me close the. Yeah. So you said, can I get the ID? That's true. So if I group by truth, uh, and if I do ID and I click on column setting, and this ID count, I can convert this ID count to row ID. Say three, since 3 images have been visualized here. So uh, yeah, this image. Okay, so you want this to be on image basis. Got it. Let me do it again for you. So if I go by table and see the ID, and I want to see images, I don't want this class chart here.
I think it's already doing it. Like it's getting the file names by the left. Yeah.
Let me do like I just showed it a while back, and I'm forgetting it myself. Just a second. Yeah, got it. So let's first filter to one class. So say the truth is complex and like guess is not complex, and apply. And you can see first you can see which images the prediction was wrong, and then you have to individually look at the image here, like, and you have to like make your own judgment that like is it mislabeled or something like that. The example that I showed earlier was uh, split. Yeah, so basically, like say for example, this image was like you felt that this image belonged to a different label. You can simply click on this column setting, row ID, and that's it, right? So this image, since it was 7 to 9, I have to go to 7 to 9 here as well just to match it up. So this image is basically the name of this image is this, and you can go back and remove this from your data set. Does it answer your question?
Yeah, it does. It does. This is really cool. Yeah.
Okay. Yeah, I mean, I talked about the dashboard, the metrics that we can log, artifacts, tables, and I will end that up with like example dashboard real quick. Yeah, so this is a dashboard that I'm using to like train models for plant pathology competition. Let me visit that competition real quick. Yeah, I started last week, but I made some good like progress. I started with my baseline of 70.8, and I'm right now at 80.3, and my current leaderboard score is somewhere like 63 or something. Yeah, 63. So yeah, and for this I used this project. It's private because like it's for my own sake, and you can see that I have arranged all the runs using this tag. So I know that this run is associated to evaluation and it's for a k-fold training. Uh, Let me show more runs here. Yeah. So like this is associated to class rate. So like I know what these tags are. So you can add your own, like create your own tag, add that, and like this is going to really organize your stuff. I was recently like I just trained a classifier with cutout augmentation, and this is the metric. Yeah, the metric you can see. I am monitoring overfitting the stuff, the system metric. I tend to use system metric to check my data loader to see if the GPU utilization is good or not. So like you can see that it's doing good. Like all of the memory was allocated and it's doing like over 90% of usage. So that's great. So yeah, I mean, I have artifacts where I have saved all the models, and I have all these tables as well, where yeah, the tables as well to see. So like I have this like just one tool, and I can use it for different components of this whole pipeline. Yeah, that's it from my end for the demo and all. Uh, I will just quickly show how you can create your team account because Srinivas asked me that question. And if you still have any question, I will totally answer that question. And I'm really sorry that I took a lot of time.
No, that's fine. It was very useful, so no need to apologize. And we appreciate you taking the time. It's almost midnight in India, so thanks for joining and going through it. I think people have already asked about the recording, so I think it'll be useful to go back and listen. Only one request is if you can post whatever links to some of those notebooks on Slack, that will be very helpful.
Yeah, I will do that. I will do that after this call.
Sure.
So how you can set up your team? Since you asked this question once, so this is a new account, like another account basically. Like if you have a new account, like if you have an account and if you do not have a team that you have created using that account, you will find something like this invite team here. So for my normal account, I already have a team, so I had to use another account just to show this. So if you click on invite team, you have two ways, academic and work. So work is basically for all the corporate use case. For academic, you just have to maybe provide in the name of an organization. So this organization can be say Kaggle study group,
TWIML. You can just say
TWIML, but I'm not going to use it because you will have it.
Yeah, that's
have it.
Yep.
Then you can even provide your custom team URL. So maybe in your case it will be TWIML or let me have something random here. Let me just name it properly. So how many collaborators? So you can do even over 100. So like say if there are say 10 to 20 collaborators. So if you can just provide a quick overview of what you are working on, so that because since Mission Basin is still like paid platform, but it's totally free for individuals and for academic purposes, even for Kaggle use cases. So like if you can provide kind of insights of what you are going to use this team, that will help like the sales team on our company just to so that they will not go and bug you later on, something like that. So like if you can just provide some stuff here for my Kaggle projects, and then click on create team. I can then invite the members by like providing the email IDs separated by comma. But for now, I'm not doing that. I click on create team, and this is my team basically. That's it. You just have to do this much, and you will have a team. This is my team setting page. If I go to my team page, this is the team page. I can create new projects. So this is will be an overview of all the projects that I have created or my team members have created. If I go to team setting, like I can provide in the email ID that was used to create a OneDB account, or I can just provide in a OneDB ID. So say it's like this is
Yeah, got it.
yeah, you got it.
That's
Yeah.
good.
So you can do that. You
Yeah.
can like invite your team members here. There are some other stuff like even for a team page, you have a 100 GB limit. So I might want to use it like judiciously. There are some settings as well. If you want to integrate with your Slack, you can even do that. Yeah, I mean there are some other features that you want to try. You can even associate a team member with member admin or like the service account. Yeah, I mean this is how you will create a team basically using SMBSS.
Great. Thanks.
You can we can only create a single team for single account. Yeah, that's true.
Yeah, got it.
But within team, so let me show my profile real quick here. Yeah, this is my profile. So I created this team Bird Listener sometime back. Let me yeah. So I created this team. So first you provide the name of the organization. Just to answer your question, Haswan, the name of the organization is going to be one, but you can create multiple teams within that organization. Yeah, that will answer your question.
Okay. So when you say org, you mean like when we said something TWIML, so under that, then you could have multiple teams, is what you're saying.
Yeah.
In the example you were going through, right?
Yeah. This is what I'm saying based on when I made a team. Like I made a team for like Kaggle competition. I created like the name of the organization was Kaggle something, and I created two teams, Bird Listener and Bird Class 21. And there used to be an icon here to like create more teams, something like that. I don't know if they have turned that off or something. So I would say like yeah, like I'm not 100% sure if you can create one organization and under or that organization you can create multiple teams, or you can create multiple, or you can just create one team in general. I will let you know from after I get some clarification on that. Yeah.
Okay, that helps. Thanks.
Yeah. That's it from my end. Any last question before I stop sharing my screen?
Hi, thanks very much for that. I was just wondering, is it possible to save notebooks themselves as artifacts?
I didn't get your question.
Can you save like the entire Jupyter notebook as an artifact?
Yeah, you can. Let me. So basic. Yeah. So this is the settings for my own profile, and yeah, there's this nice thing: enable code saving in your personal account. If I turn this on, the Jupyter notebook will be logged as an artifact itself.
Does it save it like in its sort of its
Yeah,
format
you can,
with its output cells and stuff?
Yeah, you can see it in its format with all the output cells and all that stuff. So let me like say for example, I'm not because I have like since it was turned off, I might not have any code. But if I go to an individual run, uh, so if you save a code, or like if the code is being saved, there will be another icon below this files. If you click on that, you can see the Jupyter notebook with all the outputs and everything.
All right, thanks, cheers.
Yeah.
Yeah, I have a question. Like, is there like an implementation of weights and biases with TPUs, like when you're using all cores of TPUs? How do you like make all the TPU cores to be logging their outputs into weights and biases? Is that possible?
Like, do you want to see like utilization of each core of your CPU, or like you want to use every core for logging?
Yeah, I want to see, like, let's say I'm using 8 cores in parallel to process to do a stratified training. I'm doing it's stratified training. I want to use each of the cores. How do I log the metrics from each of the cores, each of the TPU cores into weights and biases?
Yeah, so theoretically you can do that. For every core, you can call a vanDB.init, and you can, I mean, do whatever you want to do and log whatever you want to log in that core. I would say you can give it a try. I will give it a try myself and let you know. But I would recommend not to do that because based on biases itself use multiprocessing, so it might be like there might be some multiprocessing issue that you may like end up with. So yeah, I'm not sure if you should do that, but I will let you know.
Yeah. Also, another question. Sorry. When you're doing the hyperparameter sweeps, yeah, are you using like your own resources to do the continuous training? Because you mentioned something about it running in parallel. Yeah. So let's say you have like let's say a small card like a T4 Tesla card now, and you run like eight sweeps. How would that parallelization work? Will it like make all those sweeps happen at the same time on your T4 card, max it out or something?
Yeah, like sweep will use your own resources, so your local compute. It will not run the sweep on its like on weights and biases server or something like that. Is it what you're asking?
Yeah. But you said it runs in parallel, yeah? I'm trying to see, let me see if I understand sweeping. Sweeping runs like different, it runs like the same, what's it called? Same project, but with different hyperparameters, yeah?
Yeah.
But you said it runs it in parallel. So how does it run it in parallel on a single machine? On a single GPU?
Like I might have said something wrong there or something like that, or I might intend to say something else. Like yeah, like it's not running parallelly. Like if you have multiple GPUs, you can use different GPUs. Uh, Now, to answer your question, Swiss will run on your local machine like one after the other. So, like one
okay.
experiment will be done, and then it will start a new experiment based on like if it's Bayesian search, so it will be based on the previous experiment. So it will pick the hyperparameter that is most relevant and will potentially give you better results. So yeah, that's how it will provide.
Okay. So just like Optimum, Bayesian optimization. Okay.
Yeah.
That makes sense.
Yeah. Just yeah. Go ahead. Okay, just like a parting gift here. Since rainforest connection has been discussed, which is basically audio data. So you can log your audio data and it will be rendered. The waveform will be rendered, and you can even play the audio. I don't know if you can listen to this, but if I share this link and if you open
Yeah,
in your
we
own
could.
system,
At least I could. Yeah,
okay,
I could hear it.
great. Yeah, so you can listen to the audios as well. Uh, yeah, I mean, this is, you can even log the audio as tables. I showed my demo with images, but you can do the same with audio files. So like you can upload raw audio, you can like have, if you have spectrogram, you can upload the spectrogram of images in the tables, and you can do stuff that I showed. Yeah,
Oh,
that's
yeah,
it.
even a link to this would be great.
Yeah, totally. Yeah, that's it. Feel free to ask any question later on if you want.
Yeah, thanks, Ayush. Appreciate it. Any questions for Ayush? Any additional questions than what already been asked? Okay, if not, thanks a lot, Ayush. That was really helpful, and people have asked. And if I remember to, I'll do it today, but definitely by tomorrow I'll post the recording, and I'll post a chat, since there's some useful pointers there. And I know it's late tonight, it's already midnight in India, so if you can even tomorrow sometime your time post the links on the Slack channel that you used. Some of them were really handy and I think will come of use. So if you could do that, that would also be greatly appreciated. And thanks a lot for taking the time to take us through it. I think this will really help at least get over the initial hump of getting to use the tool, and then it's, as with any tool, it's a matter of figuring things out along the way. So thanks a lot for all the pointers and examples, because those are the best to learn from.
Thank you for all the time that you all gave me and the extra time that was meant for something else. But I really appreciate that. I just hope that it was really helpful. Yeah, there's a collab notebook for that visualize our data blog. I will share that as well, Joseph. So yeah, just thank you for the time, and I really hope that you can take away really good insights and pointers, and you will give it a try yourself. And just feel free to reach out to me if you have any issue, any problem. I will share this slide deck as well. There are some coordinates that if you want, you can try out. We have our own Slack community. If you want, if you like have some bugs, or if you like find some issue, you can like post it there as well. You can just post it in your own TWIML channel, and I can like take it from there and can do what's required. Yeah, that's it from my end. So yeah, I will mute myself then.
Great, thanks a lot. And also thanks to Arto for taking the lead to invite Ayush to present, and I appreciate the assist, Arto. So thanks for doing that on behalf of all of the Kaggle team members and others who joined as well.
Thank you, Ayush. I believe we would benefit greatly in the future from weights and biases services. This is just really valuable, and tables are great. I believe weights and biases provide great tools, and I hope we will be using this actively starting from now.
Yeah. Thanks, Arto, and thanks for setting this up. Like we went through the email and all that stuff, so thank you for that.
All right, cool. Thanks a lot. And we'll move to the next part of our regularly scheduled programming, which is anybody want to share their progress or issues or lack thereof with the rainforest competition? Anything that they were able to do last week? Arto, any progress on what you were trying?
I haven't had much time this week to spend on it, but I will share a nice link to, like, recently there was published a model, like source code for self-supervised pre-training for audio, and they have pre-trained models also published. It's a small model, ResNet 18. But it's specifically pre-trained for spectrograms, and also I had like a link to another repo for models pre-trained specifically for spectrograms. So I will share those, and we will see if we can just improve the performance by switching to specialized models. I think that's interesting.
Yeah, that'd be great. Thanks. Anybody else, Steve?
I haven't had a chance to run anything this week.
Okay. Again, sorry, did anybody want to say anything? There's an echo. If everybody can mute other than somebody talking, that would be great. Okay, so I'll just very quickly share just a couple of things that I was able to do. Again, not anything dramatic, no new progress as much as more of some kind of ablation studies on the setup, on one of the setups that I had already shared the details of. So I'll go ahead and share that. Let me know when you can see my screen.
Yep, see that now.
Okay, so now I'll just share with you guys in fact, it's almost like a advertisement for why I should be using weights and biases, which obviously I didn't. So if I'd used weights and biases, this would have been much cooler of a presentation and a lot more analysis that I would have been able to do. But in the absence of it, I'll just share it more in a simplified, Srinivas table form, which is not as good as the weights and biases one. But these are the various scores and the various ablation things kind of that I tried, so I can quickly explain what changes I made in each of them. The reference implementation was, I had shared last week, the original reference was this baseline all-in-one that Steve had originally used, and then a modification to use stratified k-fold. Then that one that, and as you can see, the score kind of were in the 70s for that. And then I had shared last week the ADAS optimizer using the same model, ResNest model, and that improved the score somewhat. I was curious, and we had discussed this, hey, does the optimizer really give you much of a benefit? And, or is it the fact that we introduced augmentation as we moved from the baseline to utilizing the ADAS optimizer thing, did two things: use this ADAS optimizer and also augmented the spectrograms, as we saw in the code last week. So I replaced the ADAS optimizer, kept the scheduler the same, used the scheduler to be the same, and then I used the SGD optimizer, replaced ADAS with SGD, and as you saw, that caused a drop. So, to a certain extent, I guess it's not just the augmentation, it's also the optimizer somewhat. And then, if you go into the details, and this is again kind of like relevant to what Ayush went through, the learning rate in the ADAS optimizer as opposed to the default running rate in the baseline and stuff was set to, if I'm talking from memory, but it's I think accurate 2e minus 4 or 2e minus 3, and as opposed to the baseline in this case being 0.01. So the other thing I wanted to try was if I increased with keeping the optimizer the same if I increase the learning rate to be higher, so high LR, so making it instead of 2e minus 4, making the learning rate high, same as 0.01, and then using the SGD optimizer. And as you can see, that significantly dropped the score down. So I went back in the next variation that I tried. I just wanted to use the Adam optimizer and then sticking the learning rate to be the 2e minus 4. So compared to the ADAS optimizer, the only change here is instead of the ADAS, I'm just using the Adam. And you can see that in fact gave me the best results even compared to the ADAS optimizer. So because it's 0.86 and in the private 867 and then 0.8568 compared to the ADAS optimizer. So in fact, you know, I don't know that the ADAS optimizer is anything significantly better. At least in this case, the Adam optimizer seems to do even slightly better. I kept the number of epochs and the learning rate and everything else the same. So the only change here is replacing this optimizer with the Adam optimizer and then doing everything else identical. Now, the thing I wanted to try, given that the network actually went, it uses a base rest nest model. And what I wanted to try next was in the baseline, actually, if you go through the code, you'll find that the output of the FC layer, which is, I believe, again, I'm talking from memory, about 2,400, 2400, it goes from 2400 directly to 24, which is the output. A single linear layer is what is used in the baseline, where it goes from 2400 or 2048 to directly a 24, because that's the output of the number of species of birds and frogs that we are detecting. So I thought that if I didn't do that and I replaced the fully connected layers through a sequence of layers which is used in the stratified k-fold. So it goes from 2048 to 1024 and then 1024 to 1024 and then from 1024 to the 24 that we use for bird or species ID. And so I kept the Adam optimizer the same, the learning rate the same. The only change between these two is to change the head, so to speak, and the head is a multiple linear layers with dropout and ReLU in between stuff. And as you can see from the result, it actually dropped, which is kind of interesting that I would have, if you had asked me to guess, these are somewhat explainable. This one is puzzling, or at least I don't have a good explanation of why you would get a score otherwise identical thing when you are actually gradually dropping down, because this I would think would typically either improve or at least largely remain the same. You could argue that it's almost the same, but you could still see that there is a score difference when you use a multi-layered head, which to me is somewhat surprising. If anybody has a good explanation or thought on this, that would be interesting to hear, because this is not what I would have predicted, which is the reason that I wanted to try it in the first place. I thought my score would actually increase when I did this, but that was not the case.
What's the
Any
difference
thought
between
on this
the
particular
second layer and the third layer? Is it the third one is one layer and the second is the multi-layer?
The third one is, yeah, single head layer attached to the rest nest. So the rest nest output is, and I'm talking from memory and you can look it up, but in the code is 2048, I believe. And in this case, the third example, what I did in the code is just take it from 2048 directly to 24 species, right? So it's just a single linear layer that I am attaching to the output of the rest nest. It goes from 2048 input to 24 output, right? Whereas in this case, it's a little bit more of a multi-layered network with dropout and ReLU added, and the multiple layers are, the first layer goes from, since the output of the rest nest, as I told you, is 2048, it goes from 2048 to 1024. Then there's a ReLU and a dropout. And then there's a 1024 going to another 1024, again with dropout and ReLU. And then that 1024 layer, which is, from after 2048, I have a layer of 1024, and then that goes to another 1024. And then that 1024 now goes to an output of 24. So I've added 2 additional layers of 1024 between the 2048 and the 24 output in this case. And there I find the score to actually drop compared to this layer. I mean, compared to this run using the rest nest. But typically I've seen gradual reductions. Sorry, go ahead.
To know more about the spec of your training, so do you only fine tune the head, or how do you train that? Do you do any fine tune only on the head or on the full model?
We fine tune on the full model, meaning obviously the its rest nest is pre-trained, and I just the rest nest model is pre-trained, and I fine tune the head layers in both.
Okay.
Yeah.
And you didn't fine tune the whole body, just the head.
Just the head, because this is frozen and taken from the pre-trained.
Understood.
Yeah, but how was it doing in terms of overfitting? So you are adding like tons of parameters here, right? And
right.
What about performance on training set? And how it compares?
Yeah, I haven't increased the epochs in this case. And what you're saying, if go ahead, Tendo.
Yeah, another thing that I would say is like, did you add dropouts? Because of this overfitting issue, like, did you add a bit of dropouts in new layers you added?
Yes. Yes. Each of the layers, each of the full chip layers has dropout. I forget the, like, you can look at this code to see what amount of dropout I used, but I did use dropout. Yes.
Yeah, I said like the body is frozen. The body of the model is frozen, and you're just fine-tuning the head.
Yes.
Yeah, so the data set is pretty small, and by adding like only one fully connected layer going from 2000 to 1000 adds like 2 million parameters, right? And you can easily overfit with that, even with dropouts. So I would expect that might be a problem. Also, I guess in vision applications, head is usually also should have batch norms. So that is a thing to try to add a batch
that's
norm.
That's a good point. I did not use batch norms.
Also help with overfitting usually, I guess. And so I would expect that some overfitting might be happening here.
Yeah, no, and what you said is, in fact, this is not what I expected, but then I tried something else which led me to the same conclusion. But batch norm is a good idea that I want to try just so I understand, what it does in this context. But Arto, your insight is, I think, right on the money, because what I tried here in the last run I did was I went back to using the 2K to direct 24, meaning I went back to this setup, and then I doubled the number of epochs. So here I was doing 20 epochs, and here I did 40 epochs. And you can see that it is what you said, overfit, because you can see it doesn't make an iota of difference. If anything, it dropped very, very slightly. Right? These numbers, even when I double the number of epochs from 2x, which is here I did for 20 epochs, here I did for 40 epochs, my change is, in fact, a slight drop in the private score and a, I don't know, minuscule increase, if that, in the public score. So I think your insight is right on the money, because basically this tells me that it's overfit, meaning it's not changing much at all. And I didn't look at the training and the validation loss yet to see, to confirm that, but your, hunch is, I think, backed up by this result that I see as well, that, I'm probably overfitting with so many parameters. That's probably the reason why.
Yeah, and experiments with optimizers are quite interesting. So I guess Adam is still the way to go, as it was shown many times. I think only rectified Adam in some applications performs like more or less consistently better, but also not so. And I know in FastAI community, for some applications, Ranger, which is combination of look ahead with rectified Adam, was popular, and I think that was for vision tasks. But like in general, even if you remember that big study of the optimizers, there was a paper which like compared extensively about like 10 optimizers, I guess, but like there was no like anything, there was nothing that consistently outperformed Adam, and like the benefit of Adam that it is quite robust to hyperparameters, like to you can like it doesn't change really, performance doesn't change really much when you tune the learning rate in some like reasonable bounds. So I guess that's interesting that here, like out of the box, Adam just do better.
Yeah, that's yeah. If you could, by the way, post the link to that optimizer paper, that'd be great. Yes, I think I also thought that maybe the only other thing to try here from an optimizer perspective is the RADAM, and you're saying Ranger was still even slightly better for some vision applications.
Yeah, I don't have like much experience with vision, and I haven't observed Ranger to like really get some like at least consistent improvement with like NLP tasks, but I think that on some so in FastAI forums, guys was benchmarking on some data set, and I think Ranger was the winner there.
I see.
Yeah,
that'd be interesting, because I might want to. So you're saying, Tendo, it was not consistent, it was still up and down depending on the application?
Yeah, like it works very well sometimes, but yeah, it still like depends on. I've seen Kaggle competitions that won with Adam. With Ranger, not Adam. Yeah, but Adam is usually the best bet when they just like going right into the problem.
Yeah, and the only other, yeah, so I think I'll try it just for kicks since it's easy enough to replace. And the one other thing I hadn't tried was I left the scheduler alone. And I think the scheduler, if I recall, was LR step, or and that might be something I'll play with to see whether that makes any difference. But in general, this setup without further changes based on what, for example, Arto was sharing, some of the learning from hyperparameter studies on that ResNet 18 network applied to spectrograms. I think that is something I'm at least looking at next to see whether I can implement some of the ideas from the parameters used in that example. And also, but I'll need to adjust those parameters because my baseline network is not ResNet 18, but ResNest, which says this is a larger and more capable. It's a ResNest 50 as opposed to ResNet 18. So that's, changing this to probably ResNet 18 and or EfficientNet, or in fact, based on that link, I think, was it DeepNet? It was DenseNet 161 was the other one from that link that seemed to perform the best, again, for the test data set that he was working with, which has even, it had a little more data, but I don't know how much of the frequency range and other things the spectrogram was representing. But those were things to try in terms of, what else to vary along this dimension, holding the base structure to be the same. So yeah, that's why I was curious again with some of the stuff Arto was trying to see what scores and what level of performance he got. But those were the things I was able to play with. But it definitely leads to the pointer that, time to dive into some of the other details to try and get the score further up than in the mid to higher 80s. Because we know that, people have gotten this up to 0.98. So there's still a long way to go.
Yeah, I think the score looks pretty good at the beginning, right? I have a question about the experiment result. I see your fourth experiment is pretty bad compared to other. It only has 0.60. What's the difference?
Yes.
What makes it bad?
Oh, yes. Good question. See, here I used a higher LR, keeping the optimizers the same. So a little bit of background. So when the ADAS optimizer was used with the ResNest and this basic structure, the learning rate here for this optimizer was 2e-4, and the weight decay and the weight decay I think is 2e-6. In fact, let's go check that out to see whether the numbers I'm quoting from memory are correct or not. And yeah, 2e-4, and it gives a weight decay of I think 2e-6, or no, actually this thing doesn't use weight decay. But so when I use this notebook, the ADAS optimizer at 2e-4, when I switch to the SGD optimizer, I left the learning rate at 2e-4 and I used a weight decay of 2e-6. And that gave me these results. Now, my thinking was, let me keep the optimizer the same, but when I look at the baseline here, which uses the SGD optimizer, or even this one, the STD optimizer used a learning rate of 0.01, which obviously is much higher than 2e minus 4. So I was thinking, let me try the STD optimizer and this setup, but with a much higher learning rate of 0.01. So that's what this experiment is. So obviously the the high learning rate doesn't work for the rest, for this configuration, because it drops the score significantly.
Yeah. So is it your original intention is to see if higher the learning rate could make the result comparable with others setting?
Yes, or better.
I see.
That, and in some sense, the high learning rate could also result in faster convergence. I did not, and I should probably go back and look at whether, even though it gave a lower score, whether it ran faster, that is, each of my cycles was or overall epochs ran faster. I didn't look at that, but from an accuracy perspective, these scores were a lot worse.
I see. Thank you.
And all of them use the same 5-fold stratified and average the scores and stuff like that. So the basic framework is exactly the same for all these. So that's why I was saying this is more like ablation in the sense that I'm only changing one thing at a time to see what the effect of that is. So, for example, in this case, the only thing I changed was optimizer. Again, when I changed the Adam, I went back to the same learning rate. So this, between this numbers and the ADAS optimizer, the only difference is the Adam optimizer. And you can see that it outperforms that guy. So as we were discussing Estendo and R2H, I mean, Adam still seems to be out of the box pretty good to be the best, more or less. Okay, that's all I had. And, definitely more work to do to get to where things are already at, but hopefully that will get us, I found the need now to go back to the sound videos and kind of learn a little bit more about how to change parameters to get the spectrogram to be different, the number of Mel bands to be different and things like that. And, over the last 4 weeks or so, I've forgotten what I learned. So I need to go back and figure that out once more. And yes, Arto, if you can post those links, that would be great, of the pre-trained networks on spectrogram. The one other thing, especially since many of us are in the same deep learning PyTorch course as well, one thing which I haven't yet bothered to try because I wanted to do things with the basic approaches is I found a link where there is also a contrastive learning approach that could be taken with this problem, and I haven't yet gone down that path, but that would be an interesting path to try, especially because examples are available in this case for both true positive and false positive. So you could possibly take a true positive and a false positive and say, I want these two to be, farther apart. And you can take two true positives and make them, make the network, put them closer to each other. So the whole contrastive learning approach could potentially be applied in this case too. But I've deferred that. So if somebody is interested in trying that, that would be a cool approach to try as well. And I have not yet in any of these methods used the false positive examples that are provided as part of the data. And the contrastive method will enable us to do that, use the false positives as well. Okay, if nothing else, thanks everybody for joining, and I
Oh,
will post
sorry.
the recording.
Actually, I want to
ahead.
share my part. So actually, I want to share my part previously, but it seems that my audio is not working well. So I try to join with my iPad now. So I think it's working fine. So if my audio is breaking, let me know. So I'll try to share the screen and let's see if it is working.
Sure, go ahead.
So let me know if you see the screen.
Yes, we can.
Essentially, I just start working on this competition this week. So my direction is mainly building a basic training loop so that I can keep running through it. And on the other hand, I try to do something different. I want to try out something that is called LB prompt. Essentially, I want to prompt the class weight in the public test set by some submission. So that's the two things I want to try out. So essentially, I think this table summarizes what I did. I would say right now the result is not pretty well compared with what you have. I see your baseline have something like 80.80, but it seems like the baseline I have right now seems pretty way far from it. I don't know why, so I'm trying to figure it out. So right now I'm using Fast AI because it's fast in implementation. And let me start with talking about the LB prompt. So the first submission is something like a dummy submission. I just submit the sample submission, which means in the sample submission, you have the same score across all the class. So the score is really bad. So what I do is I try to do one more thing. So essentially, I just submit based on the class weight. So what I do is just in the true positive data set, I try to get the class weight. And then by the time I do the submission, I just rank each class simply by its class weight. So the most popular class will rank top, the second one will rank second, so on and so forth. So it is a very dumb solution, and I just submit anyway, and you can see that the score is really bad. And the third method is that what I do essentially, I try to find out the class distribution in the public leaderboard. So what I do is that I just try to set the class weight. So what I do is essentially every time I do a submission, I want to find out the weight of one class. So what I do is that I try to set the class that I want to prompt to have the highest score, let's say 1. And for the rest of them, I just inject some noise in it. In this case, I inject a 1% uniform noise. So they will be uniform distributed, have an upper limit of 1%. So I just do that, and then I keep submitting that. And since we have 24 classes, as I can remember, so at the end, I submit 24 times. So since there's a random noise, so I just submit for each class, I submit 3 times to see whether this random noise have a big fluctuation. So what I want to get is that throughout this submission, I want to figure out the class distribution in the public data set. I mean the public leaderboard data set. So this is the score that I get for each class. And for each class, I make 3 attempts. So you can see across 3 attempts, the score is pretty smooth. So I would say there's not much big fluctuation, even though I inject some random noise in other class. So you can see that what I noticed is that in the public test set, the class 3 and class 18 is pretty dominant. In the class 3, if I predict all the instances to be class 3 at the top, I can get a actually pretty high public leaderboard score. And but by the time I get this score, it didn't look as expected, because what I expect is that if I sum up the score, it should be roughly 1. But it seems not so. I don't know why, because when I work out in math, I think it should sum up to 1. The reason is that from what I'm understanding, the LW rep is average across the score for each label. So each label is associated with one ground truth class. So if I do one prompt, it should activate the label of one class only. So if I do across all the class, so it should account for all the labels. But I don't know why at the end it doesn't sum up to 1, but that's fine. I just normalize it and try to figure out its final distribution. So that's the distribution I try to infer from the public leaderboard. So from that, you can see class 3 and class 18 is pretty dominant. So what I do is that in the submission, I essentially try to rank the class simply by this weight. So from what you can see, I will rank the class 3 at the top, class 18 at the second, so on and so forth. And I do the submission again based on this class weight. And surprisingly, I can get a pretty decent score simply based on this LB prompting. I would say this LB prompting, the class weight I get here is quite different from what I see in the discussion forum, because I see in this discussion forum people also try to do the LB prompting, but what they get is that they say that they find class 3 weight turn out to be 90%, but I don't know how they get this statistic, because based on what I get is it should be 8% or something. It's something I don't understand so far, but I think this is enough to give some insights for me, at least in the sense that the test set look quite different from the training set that I have. So moving forward, I will set this as my baseline. So it's around 0.72. So what I essentially do is that I try to establish a basic training loop with fast AI. So what I do is that I try to randomly split the validation set. The validation set has 20%. I mainly use the true positive data set, which only have around 2,000 data points as far as I can recall. Not that much. And then I try to do some data augmentation. Here's the config I set for the map spectrogram transformation, and the model I'll use is essentially ResNet 34. And what I do essentially try to freeze the body and fine tune the head for 10 epoch, and then unfreeze the whole body and train it for 20 epoch. And the learning rate I get here is basically get from the learning rate finder in the FastAI package. And I use the default optimizer, set the batch size to be 64. And turns out surprisingly turns out the score I get is not that great. And surprisingly, it's worse than the baseline I have. So I thought it has something to do with overfit. Oh, at the beginning, I thought it has something with, I thought it's an overfitting issue. So what I do is that I just train the head, not the whole body. I just train the head for 10 epoch and see whether it improves, but the score get worse. So I don't know why. If you guys have any insight, would be great to hear about that. So I think moving forward, what I will do is try to get this to work at least.
Here. So are you using this approach as in those notebook Srinivas shared? I mean, cutting the spectrogram into...
So do you mean which notebook I use as a starter?
Yep.
I think the starter I used is the fast audio one. Let me see if I can find it out.
So
yeah, I think it's this one.
Maybe it is using predicting on the whole spectrogram.
Yeah, so So essentially, I don't do any processing on the image. So I just feed in the whole clip.
Yeah. So as I showed, like in the previous session, with this approach, model doesn't really focus on the relevant bit of the audio, and it makes intuitive sense that it's hard to like find the time interval of interest given a whole minute of the sound with only like about 5 seconds of the important signal, and it might be fitting on the noise or doing something like that, but actually you need to improve your score. You definitely need to cut this into pieces
I see.
or treat it somehow. Otherwise, as I suggested, you can like try this approach to like basically take an inspiration from object detection.
Essentially, is it I need to make the training set more targeted, like crop it to the one that is to the part that is localized, so that the model can learn more specific to the features of that class.
Yeah, and that's what.
Yeah, in fact, that's kind of what is done in the. Sorry, Otto, go ahead.
And I just said that's the approach you were using in those notebook, and that probably explains most of the difference in the score.
I think the notebook I looked at didn't
audio.
Which one should I look at? Is it first one?
It's not these ones. There's one that I think I might have posted later. The all-in-one RFC baseline for beginners uses that kind of an approach. The one above that.
This one?
You see the one, that one. Yeah. And that's not fast AI based, but that's the one which utilizes the, you see the 10 seconds there. So it utilizes, if you go up, now this one doesn't actually implement stratified k-fold, and then there's a version of this which implements stratified k-fold. Even though he shows it, but he just uses one fold. But there's a version that uses stratified k-fold that you can adopt. But the point is, if you go up, you can see that it stay there. You see the length is 10 times the sampling rate. So he is using a 10-second window around the Tmin and the Tmax and centering the center to be, the center of the 10-second window.
So this block is trying to generate
Tmin
more
and
data.
Tmax. Exactly. But then, the thing, and it's interesting, one drawback of this feature of doing this I found is a couple of drawbacks. One is the scoring wise, because at least in validation, you're still using the 10-second chunks, even in validation. So from that standpoint, you can't use LW, LRAP, as a score, because you really, when you're scoring it in that 10-second window, you're just trying to recognize one signal. So initially I thought, okay, now, let me change the score from accuracy to LRAP, but there is no LRAP because in that 10-second window, you're just looking for one signal. I mean, it's kind of orthogonal to what we are discussing here now, Al, but I just thought last week I sat down to do that, and then I realized, because of this chunking, you can't really use LRAP as a score when you're doing the validation. And then, by the way, while we are at it, the other thing to mention is when you are doing the test, though, you do the prediction on 6 chunks and then kind of use the argmax of each of those chunks to find all of your multi-label things.
But if I do it this way, if I do it in this way, how should I train the model? Should I treat it as a single classification or a multi-label classification?
as a single. That's what I was saying right now. As a single, binary classifier.
So does it mean that because in the inference time is probable most of the time interval does not have any class? So does it mean that in the training set I need to include a null class indicating there's nothing in the interval?
Not really, right? Because in a sense, your binary training, which is you take the signal or not the signal, which is the null class. But again, keep in mind that you are using the tmin tmax, which gives you the window around which the actual signal is present. Because the data gives you the tmin and the tmax.
Oh, is it? Wait,
for
I don't
each
know.
recording.
I think in the test set, does it have it? Because from my impression, it doesn't have. You mean there's a tmin?
Yeah, but in the test set, yes, correct. But that's you use only in training. And as I was explaining, when you are testing, then you don't care. You just do the entire. You do 6 chunks of 10 seconds, and you don't care about the tmin tmax. The tmin tmax is only used to find the appropriate chunk that you convert to a spectrogram.
What I mean is that, so is it in the inference time I need to assign a class for now? Because it's probable for some interval there's nothing in the interval. Do you know what I mean?
Yeah. In fact, this was one of the things that I don't believe so, because you don't.
What I'm thinking is that if you train without null, the model will always give you a class, even though there's nothing in the interval.
Yes, yeah, yeah.
Not really, because you don't train it with softmax. You still train it with binary cross entropy. So you get like a bunch of scores for each category. So like potentially it might output a low score for the image when there is no particular category there, right? Because we don't train it with softmax, we train it with binary cross entropy, and it just that means that it just tries to like determine independently is there something like, is there category A, is there category B, is there category C, and so on.
Because what I think is that even though they treat each class is independent and we don't do any softmax, but in the training, I think the data we feed in is all of them are the true positive, right? So it means that it must have one class to be present.
Yeah. So that's not a great approach to it, and I think we also were discussing this previous session that probably we can benefit from feeding it like blank samples when you do it this way.
Yeah, exactly. So I think it has something to do with how you train the data, how you train the model. I mean, the data that you generate. Yeah, I think it's a good insight. At least I know I think probably it will explain why the score is not that great. Probably about the data that I handle. And yeah, I think that's it. I think moving forward, I think I will focus more on how I handle data. I think the way that you suggest is one thing that I will definitely do. I think it will be a main driver for the performance. I guess so. Another thing is I noticed that by the time I train the model in the kernel, the GPU utility rate is so low. It keeps at 0% throughout the training, and the utility, so it takes me around 2 minutes, 30 seconds for one epoch. I'm not sure how long does it take for your training on one epoch, but for me, it seems to be pretty slow. Based on the image we have, it should be faster.
Yeah, here weights and biases could really help because the GPU utilization is logged there, and on Kaggle, like this monitor you have, it's not really that great, at least as I see it. So it does not provide you like all the information, detailed information. But when you log your run to weights and biases, there you would see like clearly plotted GPU utilization with time, and that would like clearly indicate if you have some problem or not. But I guess
definitely,
2.5 minutes per epoch is fine.
It's fine. Do you encounter it? What is your training time? Is it similar?
Yeah, I think it's roughly the same, but I'll double check on, because keep in mind that, here what you're doing though when you're training is you're training, actually it's, what's the size of the images you're generating here?
Oh, I need to check. Wait, what is the size? Oh,
because that's the other thing that other model does.
I don't know the default from Fast AI.
It collapses the size to 224 by 400.
224 by 100. I think it's not that small. But yeah, I think image size is one factor. Probably I need to change the configuration to make it smaller.
And another thing you could do, you can add num walkers argument to data loaders to use all the CPU cores available. But I think in Kaggle you get like 2 or 4 cores. So
I think it's 4. It's 4.
Yeah, but when creating data loaders, you can set it to number of your cores.
Yeah. So I think that's pretty much it. And definitely, I would like to try out the weight and bias type, the report dashboard. So to log the model and data set, to log each experiment, and also I would like to log the prediction. So when I see the table feature, I think it's pretty useful for both EDA on raw data and also EDA on the model prediction for each data
especially
point.
What you have there of analyzing the confusion matrix. I thought that what he showed allows you to visually analyze the confusion matrix, which is cool.
Yeah. All right, so
okay, great, thanks. If you even can post a link to your notebook, even if it's not perfect, I think people can comment, learn from it and stuff too. So feel free to do that.
Yeah, I think I made my notebook public, so I will share that. And in case you see some loophole or some problem in it, feel free to point it out.
Yeah, sounds good. Thanks, Al, for sharing. That was great. And thanks everybody for joining. We'll reconvene next week. And if you have any other questions post regarding weights and bias, feel free to contact Ayush, and we'll meet again a week from today. Thank you, everyone.
All right, thank you.
Thank you, everyone.
Bye.
Thank you.